Bring on. How you doing, mate?
Yeah, good. How you doing? Apart from hating your life.
I don't hate my life. I don't mean it really. I mean, I'm on my second gin and tonic. I can't hate my life that much.
True. Yeah, 1:30 p.m. 2 gin and tonics down. It can't be a bad thing, right?
No, that's true. Now, this looks like a very well laid out cupboard. Is this like a secret streaming area that you have, and it's just like your
No,
place?
it's just my office nook. My office nook. I'm a remote worker, so I've got to have a really comfy kind of. I got to have a comfy setup spot. So
you embrace comfy all year round. I
live and breathe comfy. I would be in track pants if I hadn't have just been out grabbing lunch.
You can put track pants on. Like, we are fine with just.
Oh yeah, I probably won't do it live on stream.
No, that would be
a bit racy.
I mean,
might be a terms of service violation potentially.
I mean, I will say there is a bingo card going around. The bingo card does have a whole bunch of things, including accidental nudity on it. So we might.
Yeah, that would
Shout
be
out to
intentional then. That would be intentional, so it wouldn't be accidental.
Sorry, while you say that, yes, Bex, where are the whole pictures? We need whole pictures, please. Now that I've said that, Ben, you're going to be talking today about salsa, which I think is a really interesting topic, noting that everyone's panic last week into the XZ vulnerability in Gittins. I think it's going to be quite relevant to a lot of people. So I will bring up your slides, and I will let you get to it.
Awesome. Yes, so my name's Ben, and I'm going to be talking about the salsa framework. I recently actually just started a new role, so I've just switched over to being a principal security engineer at BugCrowd. Previously, I was at Canva and SecureStack and a few other places. For the last 2 and a bit years, my focus has been almost exclusively software supply chain security. And that's what the sort of basis of this talk is about. So going to talk about, what software supply chain security is, why it matters, and then we'll talk about the whole salsa framework, and then maybe a little bit of a spicy chat about SBOMs at the end too, because I think they just take up a lot of air. Anyways, so what is software supply chain? I think there's a lot of questions around it, because it is kind of like a quote unquote new thing. I don't think it really is. I think it's just a different way of looking at stuff. But essentially, a software supply chain is kind of the complete and total collection of everything: the code, the people, the systems, the processes that sort of build the software or create the software that you make. And to sort of narrow it down a bit more, that includes things like the code you create, dependencies, but also the software you use to build things. So your IDEs, your CI tools, everything, anything you use to package it. And it also includes the systems that you build stuff on. So those systems are made up of a set of code, and a set of dependencies, and a set of tools. It's kind of like the collection of all that information. Now that we have this software supply chain, well, we need to secure it. So software supply chain security is basically, let's secure the software supply chain. We're going to record it, including all the things that make up it, the activities, the practices, basically anything involved in the creation and deployment of software. And that's a lot of what this boils down to, that concept of recording things. So it's probably pretty important we talk about why this matters. There is a lot of reasons, and I'm not going to belabor a bunch of breaches, although they will get mentioned. Essentially, though, this is a very real threat. As we just saw with the most recent vulnerability, that was a very well-planned and executed supply chain attack. It didn't end up, going off, but if something like that had have happened and had been successful, then we probably would have found ourselves in a pretty bad spot. But other examples are, things like the SolarWinds breach, that was, malicious code being deployed into Orion, and then that's sort of imported to all these agencies and places that use it. We all know that Pipeline and NPM are just hive minds of absolute terrible things that make everyone sad every time you install things. You get 1,000,001 vulnerability alerts, et cetera, but that's not including the fact that there's a whole bunch of malicious and intentionally malicious packages within those repos that do things like typo squat and sort of hang on to names that are similar, or inject themselves depending on projects. So to sort of back this up, CrowdStrike does their global security attitude survey. They identified that 45% of respondents in the survey had experienced a supply chain attack in the past 24 months. They weren't specific about what those supply chain attacks were, etc. but really revealing is 59% of those people that were affected policy response for those supply chain attacks, kind of just deal with them by the seat of their pants. And it's sort of becoming more common, right? So these threats exist throughout the supply chain, and they happen in different ways. Whether that's, for example, I am putting code into a repository through like a malicious commit, or I'm compromising the repository. I'm building from source that I play with. There's a whole bunch of things, and these are just all great examples of things. I really enjoy the event stream one, for example, because the attacker had a dependency, and this is similar to the recent sort of ZX vulnerability. There was a dependency that existed and it was later made malicious. That sort of thing is becoming more and more and more and more common. We're seeing this happen all the time now. So what can we do about it? Well, there's a framework. So SLSA, or supply chain levels to software artifacts, no one uses the full name. We just call it SLSA. It's really straightforward, principles-based, non-vendor specific framework that sort of talks about incremental improvement for software supply chain security. And I much prefer incremental improvement. Things that talk about like becoming compliant or like just doing this thing, it never makes sense. And incrementalism is frequently the best way forward. It's a lot harder to sell though. But the SLSA framework talks about a set of levels that describe increasing security guarantees. So it gives us a way we can talk about things, and that's a really important sort of thing. So we'll talk about what the vocabulary and components of software supply chain security are. It gives you a means of securing it, and sort of a checklist as well. So controls, and we want controls because what use of policies if you don't actually implement them, right? So, like I said, the main thing we're going to talk about with this framework initially is sort of the language it gives you. And most of these words aren't unique to SLSA, but one of the words really does stand out, and that's the first one. That's the concept of provenance. So provenance has historically been something we talk about in the art world or in the traditional supply chain world. It's sort of like the record of who's owned a painting, or the record of who has touched or modified a piece of cargo or some sort of supply component. Well, we basically want to import that same methodology into software security. So provenance is the concept of the attestation or metadata that describes how the things that you made were produced. That includes like the platform and any parameters that we use to create them and things like that. We've also got attestation, which is part of that metadata thing. It's just basically an authenticated version of provenance. It's a way of saying that I've got this provenance, but I can also attest, I can state that this is valid. And then the rest of these things are pretty standard. Source and build, we kind of understand how those do. Source is the beginning of the supply chain. Build is what happens to the things within the supply chain. The ultimate end production is a package or an output. We tend to talk about it as packages, but the output doesn't always need to be a package. The output could be infrastructure as code execution. It can be a no-op. There's a whole bunch of things you could produce, but the terminology is sort of more centered around the concept of producing a piece of software. As I said, provenance, just to spend a little bit more time on it, we've probably all heard about SBOMs. Provenance is SBOMs, but there's more to it. It's not just what's in it. It's sort of the way that it was made. So the way I like to look at good provenance is it's kind of like you go to a restaurant, and not only do you eat at the restaurant, but you also get to see the safety record of the kitchen that the food was made in. It's kind of like having both those things. You want to know where your things are being made, where the things that you're eating or consuming in the case of software are being made in a place that you would be comfortable having them be in, right? And that's sort of what it comes down to. And the way we do that is by capturing every component, so all the inputs, all the outputs, and anything that interacts along the path when we build these pieces of software. So the actual framework. So SLSA is built around a set of guiding principles. There's three main guiding principles, right? The first is trust a minimal subset of platforms and verify artifacts. The logic behind this is that it's really hard to make platforms that are hard, like that are trustworthy, that are worth, that we can say for 100% these things are important. But in a counter to that, we also have to trust the platform. So the idea is that you architect your builds and you architect your application security and you architect your supply chain around the concept that you can assume that the environment you're building in is malicious, but still verify that the output you're getting is what you want at the end. This is a very difficult thing to hit. It's why you'll find it kind of later on in the SLSA framework, but it is one of the core components. It's almost like zero trust in the build environment, essentially. The next principle is trust code, not individuals. This one's kind of self-explanatory. You don't want developers being able to push code directly. They need to go through some sort of control system. We shouldn't be relying on users, like on developers and people who build our software to interact with it directly. It should be something that we can export to a trusted system, or at least to a minimally trusted system. It's kind of a combination of wanting to be able to audit things, but also just ensuring that there is a standard validation and a standard process. So it sort of like exports some of that risk away from the individual developer, which is something that we're really terrible at doing sometimes. The third is attestation over inference. We infer a lot of stuff, especially when you start talking about like infrastructure as code and software. We make a lot of inference. We always assume that things exist, or we kind of guess that those things are there. Unless we can prove it, we can't trust it. That is one of the core guiding components of this. If we can't prove it, if we can't validate that the thing that's there is what is supposed to be there, then we cannot trust it. And obviously this can go down to a level that's absurdity, right? You know, we can start going all the way down to the hardware we run on, et cetera. That's not really relevant. Ultimately, it's all about your own business's risk appetite, about where you want to draw that line. But the main thing is that we shouldn't infer anything. So now that we've got the principles out of the way, let's look at the model. So SLSA takes the software supply chain and models it as a directed acyclic graph. It's a really common component, the sort of structure we see in software engineering and CI/CD and infrastructure and stuff like that. It's basically just a flow from, you know, input to output, essentially, and everything along the way. The kind of things that make up the supply chain, though, is a whole set of these DAGs, these directed acyclic graphs. So you've got you've got one for one dependency, but that dependency has sub-dependencies and et cetera, all the way down, following it from the parent object, the parent application that you're producing, or the parent component that you're producing, and then it just gets all the way down the line, all the way down to the build environment, to the development environment, et cetera. It's a whole set of these graphs that talk about the entirety of all the things that make up your supply chain. And that's how the model sort of designs. So now that we've talked about the sort of the cruft, the fluffy bits of it, let's get to the actual levels, the things that you're sort of aiming to achieve, right? There's 3 main levels, technically 4 if you include the current state, but let's just ignore that because it doesn't really matter as much. But each level describes an increase in the level of software supply chain security. So the first level, and to be honest, is probably the easiest level to implement. Right off the bat is level 1. Basically, we have provenance. So whatever we're building, we have provenance. We have a process for builds that is relatively consistent. So we can kind of, we have an idea of what normal is, what correct is. And we have this provenance. However, it's just generated. We don't do anything with it. We don't validate it. We just have it. So it sort of says, hey, this artifact was built this way. It includes these things, et cetera, et cetera. We have it all the way down. And we can distribute that to the people that need to see it. And probably initially, you're going to find that most of those people are just internal people. We're distributing it to security and stuff like that. So level 1 is kind of like, it's a pretty easy thing to do. There's a lot of ways you can do this, and I'll talk more about like practical ways you can implement this at the end of the presentation. But it's a pretty straightforward, simple thing. But when we get to level 2, we're starting to move a little bit towards the difficult parts, right? So we've got all of level 1, but we also have dedicated infrastructure. Now, most people have dedicated infrastructure, and that's not really the hard part, right? Most of us have a CI/CD pipeline. Most of us have a Jenkins or a Bamboo, or pick whatever, Build Kite, whatever thing you're using, right? You have that. You can kind of trust it. Whether it's dedicated or not is a whole nother question. That gets addressed more in the next level. But the harder part is the fact that we have this provenance from level 1. We haven't done anything to validate it or verify it, right? Well, the level 2 component, level 2 introduces that concept, right? So the provenance that we're generating is now tied to the system that built it. through digital signatures. And I'll again go through the tech you can use to do that and the way you can implement that quite easily. But the other thing is the concept of downstream verification, or taking that provenance and making sure that it's correct. And there's a bunch of different ways you could do that. You could do multiple independent builds, a million different ways. It's kind of how hard you want to go into that, because there's multiple ways to do it. Or you could just have it so that you run a check on a separate piece of infrastructure that basically says, hey, this thing is kind of, more valid. So that's level 2. Level 3 is taking it to the whole next level. So this is where we're talking about taking this dedicated infrastructure we've built, this platform we've created, but we have incredibly strict controls on it. So this is where we start to move into ephemeral environments. So things like making sure we're running builds in non-influenceable ways. So we kind of talk about this concept in software engineering called reproducibility or hermeticity. The idea of this is that you take this reproducibility so that you could build the same thing no matter what every time. You could do it in a way that is completely isolated from everything else. You want to take that to the most extreme level with level 3. Every build runs in a completely fresh environment that's minimal subset of things, that is well documented, has incredibly high quality provenance, has a complete map of everything from the ground up. You want all of that data in there, and you need to be able to repeat that ad nauseum without any run ever interfering with the next one. So I could build one version from 3 years ago, assuming I have all the sources and everything I need for it, and that would have no impact on the next thing I build if I build one that's from today, right? So they've got to be completely separate. The other component is the idea of protecting secrets, which is something we should already be doing, but conceptually, we want to make sure that any secret material we use is kind of not accessible to user-defined steps. So no one can modify, no one can leak the provenance signing material or the signing material more broadly, but no one can basically interfere with the supply chain elements of the build. It has to be something protected and secure. Sweet. So we now know roughly what the framework is. I didn't go super deep into detail. There's really good websites and data about that sort of stuff. But what does that look like in reality? Like, how do we actually do that? So I've kind of broken it down into, I guess, 3 main controls, right? You've got provenance. We've already spoken about provenance, but it gives us the ability to see what's happening inside things. We can provide transparency to downstream consumers and upstream consumers. And we can identify when things don't belong there. So if you had good, solid provenance, for example, it would be very easy for you to identify this most recent vulnerability, because you could say, oh, I've got this package. It's this version from this source. Well, I know that I'm affected. And this can go even further down. So, for example, I am seeing work being done to use things like eDPF to essentially create runtime provenance. So not only can I see what packages are present, but I can actually see the execution paths and the CPU time consumption of those things to actually have a live understanding of the impact that a vulnerability or the presence of a risk has on my supply chain. The next big control is signing and attesting. This is probably like the main secret sauce, is the concept that we're going to not only have this provenance, but we're going to sign it, and we're going to sign all our artifacts. We're going to basically digitally ensure that everything that we produced is what we intended it to be, and it hasn't changed and it can't change without us being aware of it. And it sort of does a few key things. We obviously have a relationship between the provenance that we're producing and the artifacts. So it's like it can't be questioned. Those things are non-repudiable. We have strong relationships between who built the artifact and the output. That's another key thing. So we can see what agents built it, the person that initiated the build. All of these components are part of a piece of provenance. And when you sort of have it in place and you enforce it and you block on it, it makes compromise a hell of a lot harder, right? Because now you have to target the signing infrastructure or find a bypass around it, a way to get past it. So it's just an extra burden, right? Like nothing's a perfect control, but it's an extra burden. And the third and final control is the concept of hardened and isolated builds. Now, to me, it doesn't seem very revolutionary, the idea of hardened and isolated builds, but I also realized that I come from an SRE and a DevOps and a DevSecOps background. So this is essentially what I spent the first half of my career doing, is creating hardened isolated builds. But build is a big weakness in a lot of people's environments. It's frequently where you get your head kicked in by red teams and things like that. It's because CI environments are typically an absolute mess or a dumpster fire. So the idea is that this reduces the amount of impact that, bad platforms have. And a lot of CI platforms are essentially remote code execution as a service. That's their goal. But how do we limit the risk of that? We're also, by having hardened, isolated, reproducible builds, we're increasing the quality of the software we're producing. So not only do we get the upstream effects of increased security, but we also get downstream impacts where it reduces the burden of maintenance. And maintenance is really where, like, lack of maintenance is really where a lot of supply chain security risks come in. It's where your packages get out of date, or you install things and don't realize they're there, or you add packages to a closure and you're not sure why they're there. So by having quality builds and having quality provenance, having quality signing, we have all that information and we can have better things. We're also kind of ensuring that we have easier baselines, right? So by creating these isolated builds, we're creating a set of baselines that we can just copy and paste, and patterns are kind of the key in a lot of ways for solving things. The more patterns we have, the better. Cool. So let's actually talk about the ways we can do these things. So I've spoken about this provenance thing. I haven't actually demonstrated it, and I won't go into demonstrating it because it's kind of really boring. It's just a JSON document ultimately that contains a list of packages and a bunch of data about execution and things like that. And how deep you go down these things really depends. But to get started with this, there's some really easy things you can do. The first step is an SBOM, right? Generating an SBOM is kind of it's a relatively easy thing to do if you're using relatively modern languages and have modern CI processes, which is a dream. Most people don't, but that's okay. You can easily generate SBOMs using open source tools, and I would suggest just using open source tools because most vendors are just using open source tools under the hood anyway, right? SIFT is actually built by a vendor. It's built by SIFT, but built by Anchor. Really easy to do. Like you can just pass it a package lock file from npm, or a package or a lock from Poetry or something like that, and you'll be able to generate an SBOM. It's not going to be perfect, but it's going to give you the complete and total contents of everything in your supply chain for that piece of software. It won't give you the build environment or anything like that. So once we've got that, we can also sort of feed more information in. So you've now got your open source and your third-party risk. Well, you're still going to talk about this thing that is your application, your overarching application. So maybe you've got like a CRM that you build if you're like a SaaS product, or if you're like where I was previously working at Canva, we're building a design platform. Well, that platform itself has to have its own SBOM. So you can take SIFT's data and you can start using language-specific tooling to sort of build that yourself. You can also just put it in there, you just put your own entry in there, right? Like SBOMs are just JSON documents, you can modify them. This is only like really basic stuff. We're not going to be doing this in a super secure way at the beginning, right? So that's kind of your step one and step two. The third step, the sort of next, the big lift up, is the concept of witness. So Intodo is a framework for provenance. I haven't gone super deep into detail, but because the community hasn't really settled on what the standard is, but Intodo is kind of looking like the one. It's basically a standard for defining what provenance looks like. It's essentially a JSON schema. But as part of the Intodo project, they've also published a tool called Witness. And Witness is a really useful thing that will wrap your existing CI/CD. So say, for example, you're building a Go application and you're running Go build. Well, you can basically run Witness Go build. And what it'll do is it'll instrument and wrap around this Go build process and go, okay, cool. So what network services am I calling out to? What packages am I downloading? What syscalls am I using? And what processes are running at the time that this thing is executing? So it'll actually go and generate the vast majority of the things that you need for a good quality piece of provenance automatically for you. It's not perfect, but it kind of gets that first step, gets that big thing of like, I'm actually capturing what I'm building, getting all that data in there at once. And then once you've got that, all that's left is to attach it. So initially, we're going to attach the provenance to it. And attaching provenance depends on what your artifact is. So if it's a container, for example, OCI already has the OCI standard already has a concept of a referrer, which is essentially a referential piece of data that you can push to an OCI registry that acts as like an extra blob that comes down with the container when you pull it in. So what that means, you've probably seen this within Docker and Docker Scout or something like that before. You can actually see the contents of the container, but all the versions and all the hashes and all those things, that's a piece of provenance. That's attached to that thing, but it's probably not signed. And that's where we start getting into the significantly more complex side. So signing has historically been quite a pain. Maintaining good CIA infrastructure and things like that is quite difficult, but we're quite blessed in 2024 because the Sigstore project exists. And what makes Sigstore so powerful is two key things. It's a limited lifetime signing CA. So we're not talking about certificates that live for hours, days, weeks. We're talking about certificates that exist for 10 minutes for the purpose of signing one object. The other cool part is that it uses your IDP as an identity anchor. And almost all of it have some form of IDP, whether that's Okta or we use Keycloak or something, whatever thing, right? So you can validate yourself with the IDP, use that IDP to issue yourself the signing material you need, do the signing, it's done, problem solved. You don't need to expose too much secret credentials. And because the certificates are only valid and the certificate keys are only valid for a short space of time, you don't need to worry about compromise as much because they'd have to be there within that small window. You can even shorten that lifespan down further. If you've got your entire process down, you can generate for minutes or even seconds if you're that lucky. So the risk is extremely low. The Sigstore project maintains a public instance of Sigstore. My suggestion is you don't use the public instance of Sigstore unless you're building open source software because it has a public CT log. That's how the certificate system works. That's how it validates certificates that have already expired by using that public CT log. The key problem with that is that CT logs, as we already know, are sources of information if you want to things like email, what software people build, and things like that. So if you do care about your data not being put out, then you probably don't want to use the open source Sigstore. You can run your own instance up though. The Helm chart for it, it's very easy to do. Your documentation can be a little bit hit or miss, but by and large, if you're using a standard IDP, it's very easy to deploy. But once you've got a Sigstore instance, whether you're using the public one or you're running your own, you can use CoSign, which is the associated tool, to basically sign your attestations and attach provenance. So CoSign that's that next step bit, right? Which is now I've generated the provenance, well, I want to attach it and sign it so it can't be tampered with. And that's what CoSign basically will do for you. And in the process, also sign the container or the tarball or whatever so that you can validate that itself hasn't been tampered with. So you get a two-way validation there. Sweet. And so now we've signed things and we've got provenance, but we still got to worry about this build component. Luckily, build's really easy. If you're lucky enough to use GitHub Actions, you can actually just turn on level 3 compliant builds for a bunch of languages. It's pre-built. You can just flick it on and you'll start getting provenance, you'll start getting signing. It uses their own sort of internal stuff, so it's not as much of a privacy risk. You can point it at your own Sigstore instance if you want and stuff like that too. It's really, really easy. If you're in the Google Cloud space, you can use Software Delivery Shield. I am really impressed with SDS and the open source assured library. So you basically get SLSA level 3 compliant builds. You get a SLSA level 3 compliant runtime. You get a SLSA level 3 compliant development environment. And most importantly, you get a whole library of open source, the top 1,000, I think it is, for like 3 or 4 languages that have been built by Google and validated to be SLSA compliant, but also free of a lot of vulnerabilities. So you get access to this exceptionally good library of really important packages for people, things like NPM and PyPy and things like that. And it's just there. It's available. It's a really powerful thing, and anyone who's a GCP customer has access to it for free. You can sort of sign up to use it. So it's also just it's good to see such a thought approach. And this is not really a pro vendor thing. I think it's just because most CI agents have some sort of vendor associated with them or some clients, so you kind of got to take the wins when you get them. The third sort of part is the concept of slim environments. We've all heard about reducing the size of our build of our containers or our build environments, lowering attack surface, and there is a very valid reason behind that. We're talking about these ephemeral environments, right? So probably talking about containers or micro VMs at that point. So we want to make sure that those containers contain the minimal subset of stuff. Because then we don't have to worry so much about what's in there, but also just we just make them smaller. It means it's a quicker CI process. You don't have to copy as much data around. And there's some really cool projects that are sort of working towards that. Didn't mean to that. Some really cool projects that are working towards that. I'd strongly recommend checking out ChainGuard. Again, not a vendor promo, more so they have a huge amount of open source. They've published a complete tool chain for building incredibly slim environments based around their own custom build of Alpine. It also addresses my biggest complaint about Alpine, which is the fact that Alpine links against Musel. They provide GCC-compatible Alpine packages as well, so you don't lose the performance that you lose in Python using Musel and things like that. So it's a really, really, really cool way to instantly reduce your attack surface. But second to that, you get a massive reduction in the number of vulnerabilities. So ChainGuard images promise zero vulnerabilities. It's got quotes around it. It's zero actionable vulnerabilities. So they do a lot of the hard work of reachability analysis and things like that to check whether vulnerabilities will actually be a problem. Anyways, the last bit is just a bit of a reflection on a common pitfall that we fall into in our industry, which is that there's a lot of hype, a lot of vendors trying to push a particular way of doing things. The reality is that, as you've seen from this, SBOMs are not supply chain security. They are one part of it. They might be part of that provenance piece, but if we still build things terribly, we can have all the SBOMs in the world, but we can't validate that the things that are in that SBOM are correct or true. So I strongly suggest avoiding buying the idea that vendors providing SBOMs are anywhere near worth it. Like when someone says I've got an SBOM thing, 9 times out of 10 when I've looked at these things, they're just doing what Styft does. You can get it for free. So there are new vendors that their entire focus is supply chain security who are doing some cool stuff, and that is coming. But right now, a lot of it is hype. So just worth keeping that in mind. And that's that. Any questions?
I'm halfway through eating an M&M, so I do apologize. I don't think we've had any questions, but I think there's been a lot of interested people in trying to put this all together and not knowing all the tools. So Hoodie, Brian, and a few other people have been posting it. That's awesome. It's good to know that your Paparoo is also really interested in SLSA as well. We love that. And then the other thing is there seems to now be a competition between BugCrowd and Canva. Both amazing groups of people. And of course, who would want to go work for BugCrowd? Casey, not that I'm shouting you out at all. But yes, no, thank you very much for that. That was, how long does it take Ian to eat an M&M? A long time. So thank you very much for that, Ben. That was awesome.
Thank you.
We're going to